You know that feeling, right? You're staring at a huge list of numbers and your eyes just start to glaze over. Well, what if I told you that sometimes just one single number can unlock the meaning behind a whole mountain of confusing data? That's what we're going to do today. We are going to demystify one of the most useful tools for doing exactly that, the percentile. And listen, this isn't going to be some dry, abstract math class. No way. We're grounding this in something real, something that actually has some pretty high stakes. We're using guidance from the Connecticut Department of Public Health because we're talking about, well, the safety of the water you drink every single day. So that brings us to a really central question. When officials test water from all over a community for contaminants, like lead or copper, how do they decide if the whole system is safe? I mean, do they just take an average, or do they look at the absolute worst-case scenario? The answer might actually surprise you. Okay, so put yourself in the shoes of a public health official. This table is what lands on your desk. You've got lead level readings from 10 different sites, and the numbers, they're all over the map. Some are low, some are kind of worryingly high. So how do you make one single clear decision for an entire community based on this jumble of data? It's not as simple as it looks. And this is where statistics comes in to save the day. Instead of getting bogged down by averages or outliers, officials use a very specific tool to get a clear, reliable picture. It's called the 90th percentile rule. That's right. They don't use the average, which can get skewed by a few really low readings. And they don't just use the single worst reading, which might be just an isolated problem. The 90th percentile gives them a much more stable and representative measure of the higher end of the contamination levels. This one value is the key to their entire decision. So, how do we get from that messy list of numbers to this one critical value? It's actually a really straightforward process, and we're going to walk through it step by step. There are really just 3 simple steps to remember. First, you order the data from lowest to highest. Second, you find the position or the rank of the value you're looking for. And third, you just identify that value in your ordered list. Let's do it. All right, here's our data again, but this time we've already done step 1. We've ordered all the values from the lowest to the highest. You can see the lowest reading, 0.002, is now ranked first, and the highest, 0.018, is ranked 10th. Boom, first step is done. Now for step 2, finding the rank. The formula is beautifully simple. You just take the total number of samples and multiply by 0.9. Since we have 10 samples, we multiply 10 by 0.9, and that gives us 9. Now, this is a really important point. The number 9, that is not our final answer. It's the position or the rank we need to look for in our sorted list. We are looking for the 9th value. And here we go, step 3 in action. We go back to our ordered list, we find the 9th position, and we look right across to the lead level that goes with it. And there it is. 0.017 milligrams per liter. That is our 90th percentile value. So what does this number actually mean? Well, we compare our calculated 90th percentile, that 0.017, to the official safety standard. They call it the action level, and it's 0.015. So, because our value is higher than the action level, that's a clear signal that, yep, corrective action is needed to make the water safer. Okay, so that was a nice, clean example. But what happens if you don't have a convenient 10 samples? What if your rank calculation ends up with a decimal? Let's take another quick example from the Department of Public Health. Say we only have 5 samples. Well, 5 times 0.9 gives us 4.5. When that happens, the rule is you just take the values at the 4th and 5th positions in your list and find the average of those two. In this case, that gives us a 90th percentile of 0.019. It's just a simple extra step, but the core logic is exactly the same. Now that we see how the 90th percentile works in practice, let's zoom out and look at the bigger picture. The percentile is actually part of a larger family of statistical tools called quantiles, and they all share one simple but really powerful idea: dividing data into equal parts. You've probably bumped into some of these before. Quartiles, for instance, slice the data into 4 equal chunks. Deciles, as we're about to see, divide it into 10 parts. And percentiles, well, they create 100 tiny divisions. They all work on the same basic principle. You order the data and then find specific cutoff points. So this brings us to a really neat connection. A decile divides data into 10 parts. This means the 9th decile is just another name for the 90th percentile we've been working with. And the 5th decile, which is the same as the 50th percentile, represents the exact middle of the data. You probably know it by a much more common name, the median. So, okay, this makes sense for water safety, but how does it apply to your daily life? Well, the answer is, once you grasp the concept of percentiles, you're going to start noticing them everywhere. We've covered public health, but in education, your kid's standardized test score might come back saying they're in the 85th percentile. All that means is they scored higher than 85% of the other students. Or in finance, analysts use deciles all the time to rank the performance of mutual funds or investment portfolios. And it's not just for individuals. As this research points out, professionals like teachers and school principals get these complex reports just filled with percentile data, and they have to use them to make crucial decisions about how to guide change and improve student outcomes. Understanding this data is literally part of their job. Ultimately, this isn't just about calculation. Understanding what a percentile or decile means is really a form of data literacy. It empowers you to look beyond the raw numbers and grasp the real story the data is trying to tell. Whether it's a health report, a financial statement, or a school test result, percentiles are shaping the world around you. So the next time you see one, don't just glance over it. Ask yourself, what story is this number really telling?